The second question here says, a point traversed half the distance with velocity v0. The remaining part of the distance was covered with velocity v1 for half the time and with velocity v2 for the other half of time. Find the mean velocity of the point averaged over the whole time of motion. We will explain this question with the help of a diagram here. And please imagine that the entire distance covered by the particle or the point is s, and that distance is divided into two equal halves, s by 2 and s by 2. The first s by 2 distance was covered with velocity v0, and please imagine that a time t0 was taken for that process. And the remaining half distance, the remaining s by 2, was covered in two halves of time. In the first half of time, the particle traveled with velocity v1, and the remaining half of the time, the particle traveled with velocity v2. So if that entire second half of distance was covered in time t, I can say that for t by 2 time, the particle traveled with velocity v1, and for t by 2, the remaining t by 2 time, the particle traveled with velocity v2. Now, to find the average velocity v bar, we'll find the total distance or displacement, because it's a straight line motion here and just in one direction, so both of them will be same, divided by total time. Now, total distance is very simple here. It is s. That divided by total time will be t0 time for the first half distance of the journey and t time for the remaining half of the distance in the journey. So that will be t0 plus t. If I manage to find expressions for t0 and t in terms of s, we can now solve this problem. So, in the first part, we know that s by 2 distance was traveled with velocity v0 in time t0. So I can say that t0 will be equal to distance by speed, that is s by 2 divided by v0, that is s by 2 v0. So I have t0 already arranged, and then I have to find t. To find t, please understand that the total distance traveled in two halves of time is s by 2. The second half distance covered is s by 2. And in the first half of time, the distance covered would be the time into velocity, that is t by 2 into v1. And in the second half of the time, the distance covered will be again time into velocity, that is t by 2 into v2. Now, if I add these two distances here, t by 2 into v1 and t by 2 into v2, I should get s by 2, because that is how the journey is made. The second half of the journey, second half of the distance of the journey is covered in two different times. And now we have the distance covered in two different times. If I add that up, I should get s by 2. So I can say that s by 2 will be equal to t by 2 into v1 plus t by 2 into v2. And that is s by 2 will be equal to t by 2 taken out v1 plus v2. If I strike off 2 from both sides of the equation, I'll have t is equal to s divided by v1 plus v2. Now we have t0 already figured out as s by 2 v0. So we have t0, we have t, we can have a new equation by replacing t and t0 in the main equation. So let's try how it works out. So finally we have s divided by, in place of t0 we have s by 2 v0 plus, in place of t we have s by v1 plus v2. we can strike off s from all the sides, all the terms, and then this equation here would become 1 divided by 1 by 2v0 plus 1 by v1 plus v2. That on simplification will give us 1 by 2v0 multiplied with v1 plus v2, and on the numerator we'll have v1 plus v2 plus 2v0. That is when we take the LCM and add these two fractions. Now finally, v bar will be equal to the reciprocal of this fraction here, that is 1 by v1 plus v2 plus 2v0 by 2v0 into v1 plus v2. That will be 2v0 into v1 plus v2 divided by v1 plus v2 plus 2v0. This here is how we solve it.